Today we are going to identify the common properties of graphs of the functions of the form y equals ax squared, where a is a negative number. In the previous lesson, we learned the common properties of graphs of the functions of the form y equals ax squared, where a is a positive number. So, to identify the common properties when a takes a negative value, let us draw several graphs. I have taken three functions. First one is y equals negative x squared. The second one is y equals negative 2x squared. And the third one is y equals negative half x squared. In order to draw this graph, first we have to prepare the table of values. So I have made three tables and we have to fill them. First, I have taken the table of the value of the function y equals negative x squared. Now let us complete this table. When x is equal to negative 3, x squared is equal to 9. Likewise, means you have to multiply x value by x value, negative 3 into 3. Next, you have to take the value of negative x squared. That means you have to multiply the answer you obtained for this row by negative 1. So when you multiply the answers by negative 1, you will get the values like this. They have given y is equal to negative x squared. That means the values come to this row is the values which you obtain to this row because y is equal to negative x squared. Therefore, you get y equals negative 9. So, this will be the table of values for the graph of the function y equals negative x squared. So, the coordinate pairs will be negative 3, negative 9, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. And you can plot these points on the card. Next, let's move on to the graph of the function y equals negative 2x squared. So, in order to fill this table, first I have to take the value of x squared row. That means you have to multiply the values in this row by that value itself. Then you will get positive 4, positive 1. Then, to obtain the value of negative 2x squared, you have to multiply the values you obtain. Negative 2x squared, that means y, the value of y is equal to the value of negative 2x squared. When you complete this table, you will get a table like this. So the coordinate pairs of this graph will be negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, and table. Here also I have taken to draw the graph of the function of the form y equals negative half x squared. I have taken the values for x as negative 4, negative 2, 0, 2, and 4. You can take any values you prefer for x. No need to take these values. Okay, now let us complete this table. If the value of x is equal to negative, x squared will be equal to 16. Here it will be 4, 0, 4. When you are taking negative half x squared, that means you have to multiply this value by negative half, or else you have to divide this value by negative 2. By negative 2, we will get negative. completed table, and the coordinate pairs of this graph will be negative for negative 8, negative to negative 2, 0, 0. Now you can plot these three graphs on the same Cartesian plane so that you will obtain three graphs like this. The blue color graph represents the graph of the function y equals negative 2x squared. The red color one represents graph of the function y equals negative x squared, and this green color one represents the graph of the function y equals negative half x squared. Now you can see all these three graphs have a maximum point, and the maximum point of the function is 0. The coordinate pairs of the maximum point of all these three graphs is 0, 0. And another special thing that you can see is all these three graphs are symmetric about the y-axis. Therefore, the equation of the axis of symmetry is x equals 0. So these are the properties that we discussed. The graph is a parabola with a maximum point. The coordinates of the maximum point are 0, 0. The maximum value of the function is 0. The graph is symmetric about the y-axis. The equation of the axis of symmetry is x equals 0. These points we discussed. Now look at this point. The function is increasing when x is negatively increasing and reaches the maximum point when x is equal to 0. When x increases negatively, the function increases and it reaches a maximum point at x equals 0. And when the values of x increases from 0, then the function starts decreasing negatively. Okay, so now we have learned both the graphs of the functions of the form y equals ax squared when a is a positive value and when a is a negative value. So there are common properties for both of these graphs. They are, we obtain when a is a positive value or a is a negative value. For the graph of the function of the form y equals ax squared, the graph is a parabola. And also the graph is symmetric about the y-axis. The equation of the axis of symmetry of the graph is x equals 0. The coordinates of the turning point of the graph are 0, 0. When the coefficient of x takes a positive value, the graph is a parabola with a minimum point, while the coefficient of x takes a negative value, the graph is a parabola with a maximum point. So what you have to keep in mind is when a takes a positive value, you get a graph with a minimum point, and when a takes a negative value, you get a graph with a maximum point. Okay. Now look at this example. By examining the function, write down for the graph of the function y equals negative 4x squared the equation of the axis of symmetry. You don't have to draw the graph, you just have to examine the function and write down the answer. So we learned in the graph of the functions of the form y equals ax squared, where a is a negative value, the equation of the axis of symmetry is x equals 0. Here the value of a is negative 4. Therefore, the answer for the first one is the equation of the axis of symmetry is x equals 0. The coordinates of the turning point. You know, the maximum point of this graph will be 0. Therefore, the turning point of the function is 0, 0. Whether the turning point is a maximum or a minimum point, as a takes a negative value, the graph will have a maximum point.